All right, we're going to write our first object-oriented code. It's exciting. So what I'm going to take you through today is simply the mechanics of creating classes and objects. So I'm not going to really explain any of the conceptual stuff. We covered a bit of that already, and we'll cover some more in future lectures. Right now it's just how do you create a class, or how do you create an instance of a class? How do you make an object? So yeah, don't worry if some of this doesn't make sense right now. Basically you're just learning the syntax, you're learning how to do it, and some of the reasons why you create classes and objects should become apparent later on. This is Java boilerplate. This is stuff you're going to need to do all the time. So to declare a class, again, you start with modifiers like public or private. Then you have the keyword class. That lets you know that you're creating a class. Then you have the name of the class. And by convention, you always start a class name with a capital letter. If you don't do this in your code, you'll see your tutors throw you back the code and say, hey, you didn't follow the coding conventions. Class name should start with a capital letter. Optionally, you may choose to extend a class. So if you think back to, we had an example of the bike class, we might say that a bike is a specific type of a vehicle. So we might say bike extends vehicle. It's a more specific version of the vehicle class. And if you extend a class, your class is going to inherit all of the behavior of the class that it extends. Optionally also, you can give a list of interfaces that your class implements. So you can say this class implements and then a list of names of interfaces. So again, back on the bike, we had an interface we called movable thing. So we might say our bike class implements movable thing. And that just says it has all of the behaviors that are defined on that interface. And finally, the class body. So we start again, curly brace, starts everything in Java. Write a whole lot of code and then end curly brace. So that's the body of the class. And that's going to include a whole lot of things. Fields, methods, constants, that kind of thing. Okay, so what is in the body of the class? First of all, variables or fields. So there are different kinds of variables. There are class and instance variables that are actually defined on an object. So class variables are shared amongst all instances of that class. The instance variable is only owned and only visible to a particular instance of that class. The other kinds of variables that you can have, we've encountered already. So local variables, where you just define them in line in the code somewhere inside a method, and the method arguments themselves, or the parameters. So these are the three different kinds of variables. So we've just introduced a new kind, which is these class and instance variables. All right, so if you have a member variable, one of these class or instance variables, it's going to look like this. You have, again, modifiers, public or private. In the case of a class variable, static, just like we did for the methods. It's going to have a type. So again, type always comes before name in Java. And then finally, the name of the field. All right, so we'll see an example of this in just a sec. There's a special kind of a method. In fact, it's not really a method at all in the traditional sense, but there's a special kind of method called a constructor. It's a method that is automatically executed whenever you create an instance of that class. And the constructor is special. You do not have to declare a return type. You think about it, what does a constructor return? It returns an object of the type that it's constructing. So you don't need to say what the return type is. And the name of the constructor must match the name of the class. So it always has the same name as the class it's defined on. Every Java class has a constructor. Whether you define one or not, every Java class has a constructor. If you don't provide one, the compiler is going to just call the superclass constructor. Now, every Java class has a superclass. Again, even if you don't say extends, every class has some superclass. So if you don't say extends, does anyone know what type that your class is going to extend if you don't say what type it extends from? Every Java class extends eventually from this one type. I was just seeing if anyone's actually read through the Oracle tutorials. I heard it. Object, yes. Okay, so if you don't say what type you extend from, your class automatically extends object. Object is the top of the Java hierarchy. Everything eventually inherits from object. Okay, how to create an object, how to create an instance of a class. So the statement has three parts. You declare it, you declare a variable of the type, so you give the type and the name, you must instantiate it. So you use the new keyword to create a new instance of a value. And then you might want to initialize it in some way. So you call the constructor. If you call it with parentheses empty, that means call a constructor with no arguments. If you call it with parentheses and some values in between, you're calling a constructor with some arguments. And we'll look at some examples of this. Okay, how do you use objects once you've created them? If you're looking at code that's within methods written on the class, you can just access the fields and methods of your instance directly by using the name of that field or method. Outside of that class, you're going to need to qualify that call in some way. And so if you're calling methods on an object, you're going to need the name of the object followed by the dot operator and then the name of the method. And it's the same thing for fields. The name of the object, dot, and then the name of the field. So this is how you access fields or methods of an object from outside. And if you're calling a method, again, you need to pass the arguments to the method. Empty parentheses means calling the method with no arguments. If you put values inside the parentheses, you're passing in arguments to that method. Okay, last mini quiz for today. This should be O01. And I've opened it. Okay, I'm going to leave that open and carry on, see if I can show you an example of objects before the end of the lecture. So let's create our first class, our first interesting class, I should say. We're going to create the first class that we create instances of. We'll call it person. And this is a simple example that we're going to come back to and expand over the semester. To start with, what kind of things do we know about a person? What's a thing that, I don't know, identifies a person? Name. Name sounds good. Gender as well, yeah, that's a good one, but let's go with name. Okay. Gender will give me an opportunity later on to show you about some more complex things like enum types maybe. Okay, so let's give a person a name. All right, why have I written private there? Typically, you will want to define all fields on your class as private unless you have a good reason otherwise. Right, and the reason for that is, we call it encapsulation. You want to limit the amount of change or modification that the users of your object can do. Unless you want someone to change the name of a person, you should make it private, right? Okay, so a person has a name. Let's give them one more thing. Let's give them an age as well. So person has an age, and we'll just make it an integer, so it's an age in years. Okay, so right now we have this class person. Every instance of a person is going to have a name and age, and it's going to be different for each instance. Right, we want to do something, we want to be able to construct people. We want to be able to create them. So let's do that. Let's create a constructor. We'll call it person. And in this case, we could have a default constructor that just looked like this. A no argument constructor. So this is a constructor that doesn't accept any arguments. But we want to construct a person that has a particular name and an age. So let's do that. You can see we can pass parameters to a constructor. And when we initialize the person, we want to actually set the values of these. And so we can use the this keyword to indicate that we're setting fields on this object. This dot name equals name. This dot age equals age. So what that means is take the value of the parameter that we passed in here and assign it to the value of the field name on this object. And then do the same thing for age. Okay. And, okay, this isn't very interesting so far. It doesn't do very much. We're actually going to need some code that creates a person of some kind. So let's create another class. I'm going to call this objects. And let's actually create some people, some persons. Okay, this is just ordinary Java code. So how do we create a person object? Well, first of all, we need to declare a variable of that type. Let's call the person Josh, and let's create a new instance of person. And okay, what's the name? Well, it's Josh. And what's the age? How old am I? I'm 39. Okay, so there you go. Everyone knows my age now. Right. That's how you create a person. Okay, so this isn't real interesting at the moment. So we might need to do something, like what happens if we print out something? Let's just print out the object Josh and see what happens. So let's run this code now. I've created an object. I'm going to just try and initialize it and then print it out. Okay, so that actually printed out some garbled nonsense. Does anyone understand why this printed out?
Address. Yeah.
It's kind of an address, isn't it? Yeah, this is actually this is going to print out a hash code of this object, which the default hash code for Java ends up being something like a memory address. Of course, it's given the type, so that's kind of useful. We can see that it is a person, and then it's got some machine-readable junk on the end. That's not very helpful. So we might want to define a new method. And a very common method that you're going to want to define is called toString. This is really useful. You'll want to do this for most of your object types. Okay, what's a good string representation of a person? Let's just write out their name. Okay. In fact, let's write out both their name and their age. So print out the name, put in a space, and then we'll print out the age. Okay. So now, whenever I print an object of type person, I should see the name followed by the age. So let's do that. Okay, so we're running that code again, and now we get a nice printout. Josh, 39. Okay, why did Java know how to do that? It actually knows to call the toString method. Whenever you pass something to system.out.println, it knows to call the toString method. There's actually one other thing I should have written here. Just to make this really clear, I should write this keyword here, override. What does that mean? It simply means that this method is overriding the default implementation. So before we were calling that default implementation that printed out some garbage about the memory location. Now we're overriding that default implementation to return name and age. Okay. So now it should be apparent that we can actually create multiple people. So, okay, let's create another person. Give me a name.
Harvey.
Harvey. Okay. Harvey's name is Harvey, I guess. And how old is Harvey? 24. Okay, cool. So it should be apparent now that if we print out these two different objects, one after the other, we get different values. So okay, so first we've seen the information for Josh, then we've seen the information for Harvey. In both cases, we're calling this toString method. So each time we're calling the toString method. But the first time we call it, we're calling it on the Josh object. And so we're going to use the values of name and age for Josh. The second time we call it, we're calling it on the Harvey object. So I could even, to make this more clear, I could actually write toString. So you can see we're calling the toString method on both these objects. Okay, so we're able to create as many instances of this person class as we like, and each person is going to have separate values for their for the instance fields.
Excuse me, Josh.
Yeah.
You just put in the toString methods just then.
Yep.
Does that mean if they're already there, you wouldn't have to worry about the other toString method with override above it?
No, so I'm really just making this explicit. So in fact, when you call system.out.println, it's actually just calling that method. So I was just making it more explicit that that's what's happening.
Okay.
But I mean, you can see there, to call that method, I had to use first the name of the object, Josh, then the dot operator, and then the name of the method. So yeah, I still would have had to write the toString method just like I did. Yeah.
So even with the toString on the end, you still would have written override?
Still had to write the override. Yep. So that override keyword just says, it's just kind of a nice thing to write to document the fact that you are conscious that you're overriding another implementation from the superclass. So like I know that object.toString exists.